Okay, geometry students, in this video we will be studying two forms of deductive reasoning. And I forgot to turn on my mimeopatch, so give me 1 second while I get this turned on and make sure everything is connected. Alright, here we go. Your heading today will be deductive reasoning. Please copy that in your notes. Deductive reasoning, lesson 2.5b. The other day we covered lesson 2.5a, and today we're going to be looking at lesson 2.5b. Okay, be sure and include today's date, deductive reasoning, lesson 2.5b, and include today's date. I'll pause just a second while you copy this down. Okay, moving on. Let's start off by learning a definition of deductive reasoning. Okay, so copy this definition in your notes. You're responsible for it on tests and quizzes. So please copy this in your notes. Here it is. Deductive reasoning is using facts, definitions, accepted properties, and laws of logic to make a logical argument. All right, please copy that in your notes. I'll pause just a second. Deductive reasoning is using facts, definitions, accepted properties, and laws of logic to make a logical argument. That is what deductive reasoning is. Third time, using facts, definitions, accepted properties, and laws of logic to make a logical argument. Okay? Deductive reasoning. Now, we will not be studying inductive reasoning today, but listen to this definition of inductive reasoning and see if you can tell the main difference between inductive reasoning and deductive reasoning. Okay? Don't write this down. You're not responsible for this. Just listen to it, unless you want to write it down, but you don't have to. Inductive reasoning is using previous examples and patterns to form a conjecture. Now, watch carefully, please, students. We're using patterns, we're using previous examples, and we're making a conjecture. And a conjecture, of course, like we've talked about before, is something very similar to a hypothesis. Deductive reasoning is really coming to a decision and making a logical argument. So deductive reasoning is you're using facts, not examples, and you're using definitions and properties and laws, not patterns. Okay? And you're doing this to make a logical argument, or in other words, an argument that you can pretty much prove. Okay? And down here with inductive reasoning, you're looking at examples and patterns and you're forming a conjecture. Remember, we did this the first week of school. We looked at patterns and we predicted what the next picture would be, or the next number, what the next number would be in a pattern. Okay, so that's the difference between deductive reasoning and inductive reasoning, and what we're going to be looking at today is deductive reasoning. All right, let's continue on. Now, for the remainder of this video, we're going to be studying two types of laws of logic. Okay, two types of laws of logic, and I would go ahead and write these in your notes. Okay, so here they are. Please write these down. Number one, the law of detachment. The law of detachment. That's number one. Okay. Number two, the law of syllogism. This G right here has a sound like a J in jump, a J. Okay, so law of syllogism, law of detachment, and law of syllogism. Please copy these down. These are the two laws we're going to look at today. We're going to study them. I'm going to give you a definition for the first one and some examples. I'm not going to give you a definition for the second one because the second one is really, the definition would not be helpful as much, and so we're just going to look at examples of the law of syllogism. Okay, so here we go. Let's go ahead and jump into this. Please copy this down. There are two types of laws of logic we're going to look at today: the law of detachment and the law of syllogism. And here we go. Okay, let's start off by looking at the law of detachment first. Please take some really good notes. Okay, copy this definition in your notes. You are responsible for this, and I'll explain what it means in just a second. The law of detachment. If the hypothesis, we've studied that before, of a conditional statement, we've studied that before, occurs, or in other words, it's true, then the conclusion will also occur. Okay, copy this down, please. The law of detachment states this: if the hypothesis of a conditional statement occurs, it's true, it happens, it occurs, then the conclusion will also occur. And this is the law of detachment. Okay? The conclusion will also occur. If the hypothesis of a conditional statement occurs, then the conclusion will occur. Please write that down. Now, I know it doesn't mean a whole lot to you, but let me explain what that means. Please take some really good notes. A definition is great, but looking at an example will really help clarify this, okay? So here's an example of the law of detachment. Copy this in your notes if you would, please. Copy this down. If you wash the cotton t-shirt in hot water, then it will shrink. Please copy this in your notes, students. I'll pause just a second while you copy this down. If you wash the cotton t-shirt in hot water, that should be water. Sorry about that. I do know how to spell. In hot water, then it will shrink. All right? Okay, now listen to me carefully. Write this next statement down. You wash the cotton t-shirt in water. You wash the cotton t-shirt in hot water. So then tell me, students, what is going to be the outcome? If you wash the cotton t-shirt in hot water, this is your hypothesis, then it will shrink. Now listen to me, this is your conclusion. Now look at the law of detachment. If the hypothesis occurs, in other words, you did wash the cotton t-shirt in hot water, then the conclusion will also occur. So you did wash the cotton t-shirt in hot water, so what did happen? The t-shirt shrunk. Please write that down. There you go, that's it. It's that easy, guys. The law of detachment is simple. The law of syllogism is a little more difficult, but not much. Both of these laws are pretty simple. Here we go again. If you wash the cotton t-shirt in hot water, in other words, water, of course, water, then it will shrink. Well, you choose to wash the cotton t-shirt in hot water, so the t-shirt shrunk. That's the conclusion. Okay? Pretty simple. Let's try another one. Here we go. I know this looks like common sense, but I want to make sure you understand this. I would rather bore you than lose you. Now here we go. Please copy this in your notes. Here is another example. If x has a value of 7, then 2x minus 3 has a value of 11. And that's totally true, by the way. If you put 7 right here in for x, 2 times 7 is 14, and 14 minus 3 is 11. Okay? So if x has a value of 7, then 2x minus 3 has a value of 11. This is your hypothesis. This is your conclusion. Now, if the hypothesis is true, or if it occurs, then we know the conclusion will occur. So let's see what's next. Write this down. X does have a value of 7. I'm telling you that, okay? It's true. X does have a value of 7. So if x has a value of 7, then 2x minus 3 has a value of 11. Now I'm telling you x does have a value of 7. So on your own, I want you to go ahead and write the conclusion that you can come up with. Okay? Go ahead and write the conclusion you can come up with. X does have a value of 7. And up here, we learned something, that if x had a value of 7, then something would happen. So let's see if you can write the conclusion on your own. I'll pause just a second. If x has a value of 7, then 2x minus 3 has a value of 11. X does have a value of 7. So the conclusion is 2x minus 3 has a value of 11. Pretty sloppy, but I'll read it to you. 2x minus 3 has a value of 11. That's your conclusion. Okay? All right, let's try just one more. Okay? Just one more, then we'll go on to the law of syllogism. If you study at least 2 hours for the test, then you will pass the test. Please copy that in your notes. I'll pause just a second. If you study at least 2 hours for the test, then you will pass the test. Okay? Copy that down, please. If you study at least 2 hours for the test, then you will pass the test. Okay, now, oh wait just another second here. Alright, now I've got my good fellow Ohio State fan in the room, Libby, there, and we're going to say that Libby studied for at least 2 hours for her test, okay? Which probably didn't happen, just kidding. But Libby studied for at least 2 hours for her test, okay? So I want you, in your notes, to go ahead and write the conclusion. What conclusion can you come to? Now don't forget what I said here. If you study for at least 2 hours, you will pass the test. Libby studied for at least 2 hours, so we can come to a conclusion. And this is called the Law of Detachment, okay? What conclusion can you come to, students? I'm going to wait another second while you write down your conclusion. Should be pretty simple. The conclusion is Libby will pass her test, okay? That's the conclusion that you can come to. I hope you're getting this, students, okay? So, if you're given a conditional statement, an if-then statement, and your hypothesis comes true, then you know for sure your conclusion will come true also. And this is called the Law of Detachment, okay? Now, I hope this has made sense. Let's move on to the other law we are going to look at today, and that is the Law of Syllogism, okay? So make notes somewhere in your notes, make a note somewhere in your notes that we're switching over now to the Law of Syllogism. The Law of Syllogism. Now, I'm going to bypass a definition for this law and jump right to examples. I think it would be a lot easier to understand than giving you a real long example. Now, in the Track 1 class, we go into a pretty long example. We say P implies Q, and then Q implies R, thus P implies R, just stuff like that. Okay, we're not going to worry about that in this class, but I do want to give you some examples as to what the law of syllogism is so you understand it and so you can use it. So here we go. Please take some really good notes. Are we ready? Copy this down, please. If the daily high temperature is 10 degrees or less, then the water in the pipes will freeze. If the daily high temperature is 10 degrees or less, then the water in the pipes will freeze. Now watch this. See this part right here? See my then part? Well, notice in this conditional, I start with my then part. So if the high temperature is 10 degrees or less, then the water in the pipes will freeze. If the water in the pipes freeze, then the pipes will burst. Are you seeing this okay? If the temperature is 10 degrees, then the water in the pipes will freeze. If the water in the pipes freeze, then the pipes will burst. Are you seeing this okay? So, write this down please. The daily high temperature is 8 degrees. So, what conclusion can I come to? Now read this very carefully. If the temperature is 10 degrees or less, then the water will freeze. If the water freezes, then the pipes will burst. The daily high temperature is 8 degrees. Now notice this comment right here satisfies this hypothesis right here. Totally. If the daily high temperature is 10 degrees or less, and it says right here the daily high temperature is 8 degrees. So, since the temperature is 10 degrees or less, I know that the water in the pipes froze. And I know if the water in the pipes froze, then the pipes burst. So, because I know the daily high temperature is 8 degrees, then I know what? The pipes did burst. Okay? I know that for a fact. That's called the law of syllogism. We call this part P, this part Q, and of course if this is Q here, then this would also be Q here, and we call this R. If P happens, then Q's true. If Q's true, then R happens. Thus P being true makes R be true. Now you don't have to understand all of that. Just listen again to the example. If the high temperature is 10 degrees or less, then the water will freeze. If the water freezes, the pipes will burst. The daily high temperature is 8 degrees, so what happened? The pipes burst. That's the conclusion I can come to. And this is called the law of syllogism. Okay, let's try another one. Copy this down, please. If you throw the ball to the right, it will hit the window. Copy that down, please. If the ball is thrown to the right, it will hit the window. Please copy that down. Now, notice my conclusion, it will hit the window. So I'm going to start my next sentence with, if the ball hits the window will break. So, if the ball is thrown to the right, it will hit the window. If the ball hits the window will break. John threw the ball to the right, so what conclusion can I come up with? Okay? And we're going to do just one more of these, and I'm sure I'm really boring you, but I'd rather bore you than lose you. I want you to understand the difference between the law of detachment and the law of syllogism. Okay? All right, here we go. If the ball is thrown to the right, we know it will hit the window. If the ball hits the window will break. And look what John did. John threw the ball to the right. So since the ball went to the right, it hit the window. And since it hit the window broke. So my conclusion is, because John threw the ball to the right, the window was broken. We'll put was. Window was broken. Okay? Not too difficult, guys. Really, it's pretty cut and dried. Okay, I'm definitely being boring, repetitive, but let's look at one more, and then we're finished for the class period. Okay. If you work hard in this class, you can make a good grade. Please copy that in your notes. If you work hard in this class, and by the way, that's a true statement. If you do work hard in this class, you can easily not just pass the class, but make a good grade. Easily, students. This is not a difficult class. If you work hard, you can make a good grade. If you make a good grade, your GPA will go up. Okay? If you make a good grade, your GPA will go up. So, if you work hard in the class, you'll make a good grade. If you make a good grade, your GPA will go up. The student worked hard in my class. So, go ahead and write the conclusion, please. What happened? Okay, think this through. I'm just going to pause while you guys write your own conclusions. If you work hard in this class, you'll make a good grade. If you make a good grade, your GPA will go up. The student worked hard in my class. So, because the student worked hard in my class, he or she made a good grade. Because he or she made a good grade, their GPA went up. So, the final conclusion is, the student's GPA went up. Okay, guys, it's really not too difficult, okay? I hope this is making sense. If you have any questions, don't hesitate to call or email, okay?